Unit 5. The main objective of Unit 5 to learn the different FPGA architectures and testability of VLSI circuits. Here from the Unit 5 discussing about the integrated circuits types and afterwards FPGA concept. Here the IC is a set of electronic circuits on a small chip. Here there is a levels of integration. First one, SSI. It means small scale integration. In the year of 1964 has introduced in America. The transistor count was 1 to 10 and MSI medium scale integration in the year of 1968 has introduced and the transistor count was 10 to 500. Next one, LSI large scale integration in the year of 1971 has introduced with 500 to 20,000 transistor count. And the important one, VLSI very large scale integration in the year of 1980 has introduced with 20,000 to 1 not 1 lakh 10 lakh transistor count has introduced. And finally ultra range scale integration in the year of 1984 with the count of 10 lakhs and more. So basically the one by one stage the transistor count has increased here. Here there are using as a implementation technology is transistor logic, emitter control logic, MOS, either a NMOS or CMOS logic, they are used in the IC. And the next slide is FPGA, field programmable gate array, that is called FPGA. Here the diagram of IC. So each programmable basic logic cell they have given that, and this one programmable interconnect. Complex PLDs are called field programmable gate array. FPGA is larger and complex than PLA. FPGA are growing rapidly and replace TTL in microelectronic system. The programmable interconnects allows the logic blocks of FPGA to be interconnected based on the need of the system designer. These logic blocks and interconnects are programmable after the manufacturing process. Here there are essential characteristics of FPGA we have to see about that. There is no mask layers or customized. There is programmable basic logic cells or interconnect, and the third one is core with regular array of programmable basic logic cells, and fourth step is matrix of programmable interconnect surrounds the basic logic cells. Programmable IO cells surrounds the core. Design turnaround in a few hours. The building blocks of FPGA are logic cells grouped as a configurable logic blocks, and input output blocks programmable interconnects. Here the features of field programmable gate array. None of the mask layers are customized. So the same characteristics only here following that. Okay. The logic cells. The logic blocks in the FPGA have less number of inputs and outputs. The most commonly used logic blocks is the lookup table. Next, IO blocks. Every block is configured individually to support a particular IO standard. This allows the FPGA to work with devices or interface using multiple IO standards. Third one, programmable interconnect. There is a different types of connectivity. One is single line connectivity, double line connectivity, and third one is a long line connectivity. Fourth one is a global clock line connectivity. So this interconnects meaning is a switching matrix employs the structure of 6 pass transistor per cross point. The advantages of FPGA is shorter time to market, able to reprogram in the field of fix bugs, and finally less non-recurring engineering cost. Disadvantages of FPGA. FPGA is slower than ASIC, application specific integrated circuit, that is ASIC. Can't handle complex design. It is to functioning the easily designed to operate, and consumes more power. That is the major disadvantage of FPGA. Thank you.